Alright, today I'm going to walk you through some of the basic steps you're going to need in order to find acceleration from a video. The first thing that we want to do is just think about the equation for average acceleration. So that equation is A, which is acceleration, is equal to the velocity final, which means the velocity at the end, minus velocity initial, so the velocity at the start, divided by the total time. And so that total time has to do with the time that it took to go from V initial to V final. So what I'm saying there is you're going to look at a start of a video and you're going to look at the end of the video to find the velocity here, and that's going to be V initial. And you're going to look at the end of the video and we're going to call the end V final. And the time in between, whatever you call the start and the end, we're going to call that the total time, which goes on the bottom of this equation. So if you look at this, really what we're after, we're going to look at the start, and we're going to call it the initial. That's going to eventually be plugged in here. The final is actually going to be plugged in before V initial, since you're finding the change. Anytime you find the change in something, you always do the final minus initial. And then we're going to divide that by T. That's the total time. Okay, and so I've pre-recorded a video of a pullback car, and I am going to do the kind of thinking that you're going to need to do in order to do the pullback car lab. And so I pre-recorded some videos. This video right here is playing through my iPad, which was filmed from above. As you can see on here, I can write on the screen. There are some vertical lines on here. Those vertical lines happen every 5 centimeters. So I need to know that information in order to do that, to do the stuff that to find the V final, I need to know the distances in between those marks. So just for your reference, I'm going to write a 5 centimeters up here for the spacing between each of those marks. Let's put it down so you can see that. There it is, 5 centimeters. Now, the nice part is, let's take a look at this video. As you can see here, the acceleration is not as great as some of the earlier videos I've shown you, and the reason why is if I pause the video right in the middle, I have added metal washers to this. And so that's causing the acceleration to be less than if there were not any metal washers on it, and that's the whole purpose of the lab. Tomorrow we're changing that, something about the car and measuring the acceleration. So real quick, I'm going to write down the time that it started to move. So in order to do that, the cool part about this app is you see my finger, I just slide along and time goes on. So I'm going to move to the right until I start seeing it go. There it goes. Okay, I'm going to call that my start, and as you can see on here, they put a timestamp on that. So that's 0.1 second. Okay, 0.1 second. So I'm going to write that down right here. This happened at 0.1 second. That's when it started to move. Okay, now the nice part here about this video is that it started from rest. As you see, the video, when you start from play, it was starting from rest. It wasn't moving at the start. So one thing we know, anytime something starts at rest or goes to rest, anytime something stops moving, we automatically know. And one way to check is to go right before 0.1 second. So let's look. Notice if I go back a frame, notice it's not moving. 0.6, 0.5, the cart's in the same place. So we know that's at rest. So if it's at rest, we know that the velocity in that case is 0. Okay, so we know that's 0. And since we're going to call it the start of our video, we're going to call that the velocity initial. So you don't even need to do any calculations in order to find V initial in this case, because you can just look at the video and see that it's at the start, it's not moving. Now at the end of the video, it's a little bit different story. At the end of the video, wherever you want to call the end, I'm going to call it somewhere around here because as you can see as it goes on, the car is no longer accelerating past, I'd say somewhere in here. So I'm going to stop it right there where the wheels are just in front of this red line right there. I'm a little bit off on my dot there, but you can see there's a red line right there. Okay, so I'm going to call that my where I want to start looking for V final in this case. Okay, and so again, I'm going to go to a different color blue for V final. I want to find V. Oops, I want to find. Let's get rid of some of the mess on here. I want to find. Oops, I don't know what I'm doing there with that button. I want to find V final. Okay, I want to find that. And so I'm calling that the start of V final. And so that time stamped right there is 2 seconds, 2.06 seconds is where that video starts. And then I want to go to the next part where it crosses the next line. So I'm going to take my finger and I'm going to drag it to where I think it crosses the next dim line on there. I'm hoping you can see that. I'm going to say that's the next point. And on my screen it says that that's 2.23 seconds. Okay, and so the time that it took for it to stop, or for it to go through that motion, is going to be 2.23 minus 2.06. And so we're going to come back to that here in a second. And since it moved from this line to that line, that's one line spacing, we already know that one line spacing is worth 5 centimeters. Okay, so we're going to take all that information back to the other page.